So back to the unit circle. Where is sign negative?
The second quadrant.
Remember, sign is measured on the y-axis. So it's positive here, and it's negative here.
So third and fourth.
Yes.
Okay.
So we have to find an angle in the third and an angle in the fourth. How come? I have the entire circle. Okay. So now, in the third quadrant, it will be pi plus the reference angle. In the fourth quadrant will be 2 pi minus the reference angle. So if I ask you, which angle has sine 1/2? What would you say? Forget about the sine. Sine of what angle is 1/2? It's the smallest angle.
45. Oh,
So,
sorry.
so let me refresh your memory on sine, cosine. So, and a pi over 6, pi over 4, pi over 3. 1/2, 1/2. Square root of 3 over 2, the square root of 3 over 2, the square root of 2 over 2, the square root of 2 over 2. The smallest with sine is always 1/2. And then that's all you need to remember, because the rest should come to you. So this is the reference angle here. So pi plus pi over 6. So we have x equals pi plus pi over 6, which is 7 pi over 6. It's this angle. But we also need one in the fourth quadrant. So this will be 2 pi minus pi over 6, which is 11 pi over 6. 7 pi over 6, 11 pi over 6. And now I have to study the sine. Okay. Where is the second derivative? Right here. Which portion of all this will be a waste of time to study the sine for?
Denominator.
Very good. So now I'm going to plug in 0 to study the sine here. How much is sine 0? So one more time, sine is measured on the y. Sine is measured on the y-axis. Up, down. So at 0, what is the y value at 0?
0.
0. So then I have -1. Now I'm going to plug in, this is between 3 pi over 2, right? 3 pi over 2 is between these two. Right here. This is 3 pi over 2. This is one angle, and this is the other angle, right here. So this is right in between. 3 pi over 2. Oh, right here. How much is sine 3 pi over 2? It's measured on the y-axis. How much is sine 3 pi over 2?
That one is 1. -1.
Perfect. How much is 2 times -1?
-2.
-2 plus 1.
-1.
With minus in front.
1.
Now we plug in 2 pi. The answer has to be the same because 0 and 2 pi are the same angle. So I can copy from here. So here's what I know. Seven pi over 6, this value, which I don't have just yet, I will plug it in a moment, is an inflection point, IP. The second derivative is 0 and it changes sign from opening down to opening up. 11 pi over 6, whatever, is an inflection point. I will determine these in a second. Why? Because the function changes sign the second derivative changes sign from opening up, in other words, to opening down. So in order to determine this, I have to put in the function and plug in these two values. I'm sharing my screen, going to the calculator, plugging in y equals clear, and I have natural log, and I have 2 plus sine x. Okay, so second and we had 7 pi over 6, 7 pi divided by 6, and 11 pi over 6. So 0.41, both of them, fine. 0.41. So 7 pi over 6.41, inflection point. 11 pi over 6.41, another inflection point. Very good pick, thank you. It was a good one. See, I love it when my students contribute and they find the nicest problems without my help.
Wait, sorry, could you put that back for a second?
I couldn't hear you, sorry. Say it again.
Oh, never mind, actually.
Okay. So now I would like us to choose something to put everything together and graph. So this time allow me to choose, and then you will choose the next one. Because I like to start with something simple. I like, for example, a rational function like 24. To see the whole thing. And okay. So here I'm gonna just add intervals, everything, local max interval, everything, and also graph it. And you will see how powerful you are right now. Okay. So we start with our table from the beginning. F prime, f of x, of course, on the second derivative. So you see how everything comes together and all the information will be in the table. Can anyone give us the domain of this function first? I have to start with the domain. That's our first step.
Say negative infinity to
Excellent. X squared. Everything, right? Because x squared plus 1 is never 0. Positive plus 1 can never equal 0. Excellent. So no problem. Good. Of course, 0 has to be in the table. And I would like to determine the function value at 0. What is the function value at 0?
Zero.
Very good. So there are no other x-intercepts. This is it. But I also need to determine these limits. So let's determine those limits. So limit as x approaches negative infinity from x over x squared plus 1, and then positive infinity. Where does the numerator go?
Negative infinity?
Good. Sign is not important. Where does the denominator go? In this case, it's not important.
Infinity.
Good. What do we do in the case of infinity over infinity?
So we just say
Yes, I'll help you. L'Hopital. L'Hopital's rule. Yes. So limit as x approaches negative infinity, the numerator, the denominator,
2x.
the limit,
till negative infinity.
I have,
Oh, it should be 0. Sorry, 0.
thank you very much. And it doesn't matter positive or negative infinity. And what does this say to us? When the limit at infinity of a function is 0 or 5 or 10, what does this mean?
Horizontal asymptote.
Thank you very much. So I make myself a note, y equals 0, horizontal asymptote, so I don't forget. This is it about the function. I cannot determine anything else. I determine the limits. I determine the only x and y intercept is the origin. Done. Now I can move on to the first derivative. So let's differentiate. Can anyone help? I know we've done this several times. So the top function prime is 1, so x squared plus 1 minus the top times the denominator prime. Let's see what happens now. So I have x squared minus 2x squared, negative x squared plus 1 over x squared plus 1 squared. And yes, I will factor out negative 1. And how do I factor the numerator that now is x squared minus 1? I put this minus in front, so now this becomes x squared minus 1. How do I factor x squared minus 1?
X minus 1 and x plus 1.
Good. Good. So now I have to study critical numbers or determine if the function has critical numbers. So critical numbers from f prime, so critical numbers from f prime being 0 or f prime being undefined. But there is no such thing. X squared plus 1 is never 0. So then from here, that's why I factor, so I don't have to write it again and again. So I know that there are two options. X equals
Plus or minus 1.
thank you. So then we have negative 1 and 1, 0 and 0. Immediately determine these values. So when I plug in negative 1, that's not difficult. Negative 1 squared is 1, 1 plus 1 is 2. The top is negative 1, negative 1/2. Same thing here, 1/2. Good. Now I need to study the sign of the derivative. Good, so let's continue. Where is my derivative? Right here. Which portion of the derivative I'm not going to waste my time with or on?
The denominator is always 5.
Good. So now let's plug in negative 10. Just tell me the sign with negative 10 in here. Don't calculate anything, just think. Negative, negative, negative. Sign.
Negative.
Awesome. With 0, this is easier. With 0. This piece is easier. This form is easier with 0.
Positive.
Very good. So we know what to expect, but let's plug it in. So 10, 10, 10 with minus. 10 here with minus.
Negative.
At this point, I check my table. If this row does not work well with this row, if there is any conflict, I have to go back to the drawing board. From 0 to negative 1/2, what does the function do?
Decreases.
Is that supported by the sign of the first derivative?
Yes.
From -1/2 to 0, what does the function do?
Increases.
Is that supported by the sign we found for the derivative?
Yes.
Same thing here from 0 to 1/2, and you got the drill. At this point, I can identify what this point is. -1, -1/2. What type of point is it?
Inflection point.
We didn't get to the second derivative.
That's the minimum.
Yes,
The local minimum.
right? So it is a local min because of the sequence of the signs of in the derivative. What about this point? Positive, 0, negative. 1, 0.5.
Local max.
Done. Stay with me. We're done with the first two rows. Now I have the second derivative. Messy. Messy. So let's see, maybe not. Who knows? So I'm going to copy the first derivative in this format. I'm making it as easy as possible for me to differentiate. Not this with a negative leading coefficient. Who knows? I may forget. But this in front, but x squared minus 1. Okay. No, I'm not going to squeeze it in. Let me do this. Okay. The top prime, 2x. Copy the denominator. Minus. Now the denominator prime, 2. X squared plus 1 to 2 minus 1 times the inner function, which is 2x. If you don't want to factor here, it's going to take you 20 minutes to simplify this. So please remember, 2x is out, and one of these is out. 2x and x squared plus 1. Okay, 2x is out, x squared plus 1, one of those are out, so one of them is out, x squared plus 1. This is out, this is out. So 2 distributed in here, minus 2x squared, but plus 2. One more time, 2x is out, one of these two factors is out, one of them has to be left in. What I have here is 2x and x squared plus 1 that are out. So I'm distributing 2, basically negative 2 to x squared, and negative 2 to negative 1. Yes, yes, that's one of the reasons I did that. So now I have negative 2x, and this is negative x squared and plus 3. Again, I will factor out negative 1 and terminate that. Never undefined, but the second derivative, because it's degree 3, it will give us 3 solutions. And those solutions are